of how hard it is to develop big software. Okay, so talking about best practices and talking about programming school, I want to kick into a little segment, which may be a recurring segment in future talks, called What I Learned in Programming School, right? One of the things that I learned in programming school is that anytime you write a really big function, well, you know, big functions can get really complicated and hard to understand. So if you write a big function and it looks like the function could easily be factored into smaller functions, each of which has an explicit and clear purpose, that you should do that, and that's good style and it helps you program better, right? So here at the top, I've got this function called major function, right? And here in comments, where it's got like comment minor function 1, that's just a placeholder. Imagine there's a lot of code there that does some job that you could call minor function 1, right? I'm using the comments just because there's not room on the slide to put like a whole long function. But so you've got some code that does function 1, and some code that does function 2, and some code that does function 3. And in programming school, I learned that anytime you have that, you always, or almost all, very strong recommendation that you should immediately factor those functions. In fact, you shouldn't even write it like the top version. You should write it like the bottom version, where you identify what the functions are, then you write minor function 1 as some external function with a body, and here I've put the body in ... because who knows what it is, it's probably some non-trivial task, right? So you write those as separate functions, and then in the body of your major function, you just call those functions, right? Now, there are a few reasons why that seems like a good idea, right? It's easier to understand the function as a unit, and so it seems to logically follow that then it would be easier to understand your program, since you've made part of your program easier to understand, right? You provide greater code reuse, because if minor function 1 was buried inside major function, nobody else could call it, right? But as soon as you move it outside, anyone else in your program could call it, and that's good, right? And also by externalizing these functions, making them into their own objects. Object is not the right word, but you know. By making them into their own things with curly braces, you prevent the functions from flowing over into each other, which may help you structure the program more cleanly, right? Like if all this stuff was in one big block function, then you know the lines could cross over each other and the functionality could blur, and before too long you may not even know that you had 3 minor functions, right? So that was what I was taught in programming school, and through experience I came to understand that this is wrong. And the reason is that all of those good things that I said about why you want to factor come along with negative consequences, and those negative consequences are often bigger than the good thing that you got. So for example, by factoring minor function 1 out into its own body, you make it easier to understand minor function 1, maybe. Maybe that's not even true, because maybe if you just isolated it well enough in the main body, it would have been just as easy to understand. But you know, maybe you think that makes it easier to understand, but it actually makes your program as a whole harder to understand, because you've increased the number of functions in your program, right? The number of ideas that you're juggling around. And when you factor that function out, knowledge about that code that was previously explicit in your program becomes implicit, and implicit knowledge is easy to lose. You have to like keep it in your working set all the time when you edit that code. It makes it harder to program, actually. So what are some examples of this implicit knowledge that makes this a bad idea to factor? Well, for example, who even calls this function, right? If you, if this function is just inside a big block, if it's inside major function, then you know only major function can execute this code. It's not even calling a function, it's just inline, right? But if this function is out in a file somewhere, then suddenly it's an open question, like, well, I don't know. I have to search through the code to know who calls this function, or I have to use a third-party tool to report on my code graph or something like that. So that makes things harder, right? Another question that becomes raised, or knowledge that becomes implicit, is when the function is called, right? By which I mean what needs to be true in the rest of the program while calling this function. The program could be in all kinds of different weird states, and you know, what state does it have to be in? What are the preconditions and all that stuff? And again, when it's embedded in a bigger piece of program, those questions aren't maybe completely answered, but the number of questions is reduced because now instead of 2 functions that you have to answer that for, there's only 1 question that you have to answer that for. And the fact that that other function is longer and more major may make it easier to answer. Now, when you do this factoring, you could try to provide this kind of information by commenting the function, but I claim that's not really a good idea. Okay, first of all, because writing informative and easy to understand comments is actually hard. How many of you have come to a comment later, even if it was written by you, and you're like, I don't understand what this is trying to tell me, and or I'm confused about something and this comment isn't clarifying. For me, that's actually a lot or most comments, right? But the other thing about comments is when they try to state factual information about a program, your comment is essentially code that never runs, right? Your comment is trying to express constraints about relationships between things in the program, which is what code is, right? And as we all know, code that never runs probably has bugs. Your comments never run, so your comments probably have bugs, which means they misinform people, right? And also because it never runs, your comments never get tested, which means their statement of what is true is going to diverge from what is actually true in the program over time. Because a program is not a static thing, it evolves over the course of the development cycle. So, the argument that you can make up for factoring and this loss of knowledge by inserting comments, I would claim is untrue. So, to recap that, when you factor out a function, the result of correct use of that function often depends on the outer state of the program, right? And if it looks like you can understand that function as a separate unit, maybe that's really helping you understand it, or maybe that's just deceiving you, right? And there's something subtle about the function that you didn't understand that introduces bugs. And after years of programming experience, I came to understand this at some subconscious level, but I never understood it fully consciously until I read an email that John Carmack sent to programmers at id Software in 2007 that lays it all out very specifically. Now, this is a really long email and it covers a lot of issues that I'm not going to quote from the whole, or I'm not going to read the whole thing. It would take a while. But I'm going to isolate a few spots that are relevant to what I'm talking about. He starts by talking about relatively small code base for a simpler problem, right? The Armadillo aerospace rockets. And he says the flight control code for the Armadillo rockets is only a few thousand lines of code. So I took the main tick function and started inlining all the subroutines, right? That's the reverse of the factoring process we were just talking about. While I can't say that I found a hidden bug that would have caused a crash, literally, I did find several variables that were set multiple times, a couple control flow things that looked a bit dodgy, and the final code got smaller and cleaner, right? So then later in the email, he's talking about larger games like Rage, which was his project at the time. And he says, if something is going to be done once per frame, there is some value to having it happen in the outermost part of the frame loop, rather than buried deep inside some chain of functions that may wind up getting skipped for some reason. Besides awareness of the actual code being executed, inlining functions also has the benefit of not making it possible to call the function from other places. That sounds ridiculous, but there is a point to it. As a code base grows over years of use, there will be lots of opportunities to take a shortcut and just call a function that only does the work you think needs to be done. There might be a full update function that calls partial update A and partial update B, but in some particular case you may realize, or think, that you only need to do partial update B, and you're being efficient by avoiding the other work. Lots and lots of bugs stem from this. Most bugs are a result of the execution state not being exactly what you think it is. And this last sentence is important, so I'm going to beat it like a dead horse. Most bugs are a result of the execution state not being exactly what you think it is. And so when you factor your code into more functions than you needed, you encourage that kind of bug to happen, right? And this whole idea that I've spent the last 5 or 10 minutes talking about is contrary to commonly accepted best practices. It's contrary to what I was taught in programming school, right? And thus, it's contrary to the assumptions behind many modern programming language designs, which is one of the motivations I claim behind wanting to make a language that does what us game programmers actually want to do. Now, there's a caveat to this whole worry about factoring, which John himself wanted to make sure that I put forth, which is in the case of pure functions, so that's functions that don't have side effects either to their arguments or global state of any kind, don't do input-output probably, right? Don't read global state of any kind. In the case of pure functions, you don't have any of those kinds of problems I talked about, like, when during the program can this be run? Well, it can be run any time, so it doesn't matter. So you don't have those problems, you can factor more readily. You still might want to be a little careful about it because you are, in a way, increasing the number of concepts in your program. But it's better in the case of pure functions, and that can be a goal of language design, and as it often is, and we'll come back to that later. But going back to John Carmack's email for one last point, he says, I know there are some rules of thumb about not making functions larger than a page or two, but I specifically disagree with that now. If a lot of operations are supposed to happen in a sequential fashion, their code should follow sequentially. And John Carmack is one of the best programmers in games, if not the best programmer. So when he says something about how to program, I at least take it seriously, right? Fortunately, in this case, he was saying something that I already agreed with, so it's easier to believe. But I didn't realize consciously that this is what I thought, right? And so I think there's a lot of value to people coming out and saying blatantly things like this, right? Which is one reason why I want to put forth things like this in this talk. It's not to make C++ or D or Rust programmers mad. It's to say, no, really, this is the experience that we've gained over these years, and it's important to us to leverage this experience into whatever way we may find of programming better in the future.